So thanks to you. Thanks for the invitation to have this presentation. Thanks for staying online. A warm welcome from my side. My name is Sören Röhrig and I'm responsible together with my team from the product management for the LCC calculation for rails in the voestalpine rail technology. Today, I would like to give you a short introduction how we can identify the customer's potential for saving money and reducing CO2 emissions with our new LCC Track tool and the internal stored database. Together with our colleagues from Railway Systems, we want to support our customers in making strategic decisions and to find the optimized configuration of network infrastructure for his needs and his special boundary conditions. Therefore, we support our customers by decisions of new investments, replacements of spare parts of the infrastructure, as well as the optimal time for the replacement and lifetime of the infrastructure. For this purpose, we are using our LCC Track tool, which I'm going to present you in the next slides. The new LCC Track tool is now able to calculate the entire infrastructure network as well as single elements, in case only one turnout or one curve should be reinvested. Therefore, different strategies are compared. With this feature, it is possible to represent realistic network scenarios using different configurations of turnouts or different rail grades distributed over the entire rail network. Since climate change does not stop here, it is very important also to reduce CO2 emissions and to know the potential of the reduction in advance. Therefore, the new tool includes the calculation of the annual CO2 emissions.
Sorry, Sören, we just, I think you stopped your the sharing of your slides. If we can turn that back on again.
Yeah.
Or maybe yeah.
I can do it that way if you think it's better.
Yeah, the problem is maybe Peter Veit still has the screen or something.
No.
So we need.
No, I think you just stopped sharing. Yeah. Or
just...
somebody started sharing. Yeah. No.
So do you only see me or also the slides?
Yeah, we just see yourself. Yeah, just your video. We don't see the slides. Can you start sharing again?
It seems that it is top secret what I'm presenting here.
Yeah.
I try to share it on another screen.
Yeah, it works now. Yeah.
No, it works now. And then you go to full screen maybe, with the presentation. We can see it now very well, but full screen would be nice. Yeah, that's it. Yes, perfect.
Okay, this I had it before 5 minutes, but thanks for interrupting and correct it in that way. So to show you the full potential of the LCC tool, I have prepared a demonstration example of a calculation of an entire infrastructure network. With a connection to OpenStreetMap, which might be well known, we can take the information of the alignment and the position of the turnouts as a basis for the calculation. In case of the railway network, the tool is calculating the radii automatically. For turnouts, each position will be linked in the information of the type and geometry data for further steps. After this step, different strategies need to be defined for comparison purpose. As mentioned before, a strategy is designing the entire rail network, including turnouts, by choosing different rail grades and turnouts configuration. For example, we have defined 3 different strategies. I will show you. The basis strategy, where the entire rail network is equipped with the R260 rail steel grade and the same turnout configuration. In special turnouts, with concrete sleepers, rail grade R260, a standard switch blade, and a build-up crossing is used in this case for all geometries. For the second strategy, all curve radii below 1000 meters are equipped with a better steel grade, namely R260 HT. Also, for all turnouts, this rail grade is used. Instead of a standard switch blade, load capacity optimized in case of small geometries like here the 190 radius, and kinematic gauge optimized switch blades for the bigger geometries are used. For the crossing, a cast manganese crossing is selected. As third and final strategy, we take into account that the rail grade in radii below 1000 meters are equipped with a better steel grade R400 HT. Turnouts are equipped with under-sleeper pads, so USPs, and cast manganese explosion deep hardening crossings. To compare these strategies, the tool is using the information of our internal database. For the rail grades, a table of wear in relation to the radii is stored. With the algorithm of deterioration and the wear limits, the different maintenance tasks can be defined and combined with costs and CO2 values. For turnout configuration, the information of the lifetime, investment costs, maintenance tasks, and costs, as well as CO2 values for production, transport, and maintenance are stored for each load class. With this data, the tool calculates different values, like the annual costs and the CO2 emissions, capital values, or amortization time. As one result, I will show you the annual costs. Here you can see that in case of this basis strategy, the rails are marked in red and orange line. That means that in general, the annual costs here are higher than compared to the remaining network, which is due to the higher maintenance demands combined with the lower service life. So in the second strategy, in combination of 350 HT in smaller curves and R260 rail grade for straight track, the customer can reduce the annual costs by around 30%. By using the 400 HT instead of the 350 HT steel grade, you can find the minimum of annual costs for your railway network. The high wear resistivity of this steel grade leads to less maintenance and a longer service life of the rail, which saves money for the customer. Now let's come to the turnouts. For the turnouts, the picture looks quite similar. In case of using the basic configuration over the entire network, the customer will have to invest more money for the loaded turnouts. For the second strategy, the annual costs can be reduced by around 16%, which can also be seen in the map on the green dots now. This reduction is possible due to the effect that the chosen turnout configuration needs less maintenance due to the higher wear resistivity. This effect also extends the service life and has further a positive effect on the annual costs. In case of the state-of-the-art strategy, the positive effect can be increased. With the upgrade of the R400 HT rail grade, also in the turnout, and under sleeper pads for concrete sleepers combined with an explosion deep head-hardened manganese crossing, the maintenance needs decreases to a minimum. This can be seen by a reduction of the annual costs by around a quarter compared to the basis configuration. But the decision of the turnout configuration and rail grade has also an effect of the environment. The lifetime of all the assets as well as for the rails are limited. This leads to a reinvestment during the considered period and new production of the assets. And in the production of all the assets, the main CO2 emission takes place. For longer service life, reduced to annual CO2 emissions reduces the annual CO2 emissions by nearly 30% or at least by nearly 50%, which is an enormous amount of 420 tons of CO2 for the same configuration. The same picture again can be seen for the turnouts. In the case of the standard strategy, the reduced reinvestment and maintenance saves around 11% of the annual CO2 emissions. The positive effect can be surpassed by the choice of the materials and assets of the third strategy. For this selection, the CO2 emissions can be further reduced by 23% per year compared to the basis configuration. So to sum up, by reducing the maintenance needs in combination with an extension of service life of the assets due to the optimized configuration of material and design, the customers can save 28% of his annual costs and 38% of his annual CO2 emissions of his assets. This percentage represents more than 560 tons CO2 per year. For a better understanding, it needs 7,025 trees to compensate this annual emission. So with this, I ended my presentation. I hope I made it in the right time and give you some insights how we work with our customers supported by our LCC tool.